Hello, I'm Jeff Van Treese, and this is Mobilized News. We welcome you to our show. As our guest today is Bruce Pittman. Bruce is an aerospace engineer with the National Space Society. He's done a lot of work on aerospace engineering, of course, and he's here to join us to discuss the recent breakthrough with fusion. Bruce, thank you so much for joining us today.
Great to be here, Jeff. Thanks for the invitation.
So this is the second show that we've done on fusion because it is so exciting, at least in theory. I know that there's a lot more challenges before this would ever become commercially feasible or available on a widespread scale. But can you just kind of give us your sort of 1,000-foot view thoughts on the recent breakthrough and what this means?
Yeah, so fusion has been the holy grail of energy for over 70 years now. This project quest for fusion on a serious way started back in the 50s with a government program called Sherwood, which was initially a classified program and all that, where they were going to try to do fusion. And it sounded pretty straightforward in the beginning, but turns out Mother Nature is tricky, and they've over the years have discovered over 200 plasma instabilities that make it challenging to heat up this gas, high enough to turn it into a plasma, and then contain it long enough to actually get fusion to take place. Uh, so the scientists was trying to describe the challenge, and they said doing fusion is kind of like trying to nail jello to a wall. It's very challenging, and the jello doesn't cooperate at all. There's been a number of different approaches that have taken. The one that they're used at Lawrence Livermore, the national lab for this national ignition facility, is called inertial fusion or laser fusion. So they have 192 laser beams, all converging on a little tiny pellet, and then that creates a bunch of X-rays, and that's what compresses the little gas inside. And so they were able to get more energy out of the reaction than they actually put into the little pellet, and that was a first. So they got about 50% more energy out than they put in. So that's called a gain factor. The problem is that doesn't account for all the engineering for the losses that you had to do. So if you look at the total amount of energy that they took from the grid to power all those lasers, and the amount that then actually was able to get into the pellet, it was only like 1% of that energy. So to make this an economic and a net energy producing device from a commercial point of view, you would have to take into account all those other inefficiencies, and so you'd have to get the gain much higher. So you'd probably need to do another 2 or 3 orders of magnitude, so factor of 100 to 1,000 times more gain to actually do that. It's not impossible to do that, but it's certainly going to be an engineering challenge.